All right. Thanks for joining for chapter 1.4, other types of equations. So in 1.3, we solely dealt with quadratic equations, and now we're going to look at a couple others here. So the objective is to solve radical equations and use U-substitution. Okay. Now, radical equations are simply equations with radicals, square roots, third roots, that kind of thing. So remember that exponents and roots are inverses. So if I have the square root, okay, the inverse of that would be the square. They cancel each other out. If I have the third root, okay, in order to cancel that, I'd take the third power. If I have the 2/3 power, okay, I could change that to a root, but to undo that, I just do the 3/2. I just simply inverse it, okay? Do the reciprocal of that. Make sure you check for extraneous solutions. Those are solutions that when you get it and you check them, they do not work out back into the equation. Okay? So we have here square root of x minus 3 equals 2. So we got to make sure that there's nothing outside of this square root, meaning like if I give you something like this here. Okay, see how this is outside of the square root? Okay, I can't have that. So looking here, we've got nothing outside, so we'll simply square the whole side here and square that side. Cancel and cancel, so you have x minus 3 equals 4. Add 3, x equals 7. Okay, so then I will go back up in here and check it. So I have 7 minus 3 is 4. The square root of 4 is 2, which is 2. So that's very simple. That's probably an algebra 2 beginning problem. Okay. So looking here, I've got nothing outside of my square root. So I will simply square this side and square this side. When I square it, I get 2x plus 3 equals x squared. Now you should notice we have a quadratic now, okay, which we talked about in 1.3. So I move everything to one side. We'll go to this side so that this remains positive. Okay. I think we can factor this. Factor the 3, that's subtracted 2. That's 3 and 1. X signs are different. The bigger one is negative. So let's say x plus 1 equals 0 and x minus 3 equals 0. So x is negative 1 and 3. But we need to check those. Okay, so I simply just plug it back in. So we'll start with negative 1. So these are our possible solutions. So I have 2 times negative 1, which is negative 2, plus 3, which is 1. The square root of 1 is 1, equals x, negative 1. Is that true? No. So this one does not work. Plug in 3. 2 times 3 is 6, plus 3 is 9. Square root of 9 is 3. Does that equal x, which is 3? Yes. So 3 works, 1 is extraneous. Okay, so that's algebraically how we look at it and solve it, but I can also do it graphically. Okay, I've got 2 expressions here. I've got this one and this one. If we graph both of those, I want to look at where they intersect. So if we look here and we graph it, and x, and we look at their graphs, there's one, there's the other one. I want to know, when are these 2 things equal? Well, they are equal right where they intersect. So we can simply find the intersection. If I go second, calculate, go down to number 5, intersect. First curve, you'll notice my cursor is on one of them. Hit enter, go over by the intersection and hit enter. Notice it jumps to the second one. If I'm not on the one I want, I simply hit up or down and it switches curves. So I'll go by the intersection, hit enter. Guess, you do not have to guess, so hit enter again. And we have x equals 3. Well, if you look right here, we got x equals 3. So that's one way we can check. We can also look at the table. Okay. Now, some tables aren't set up like this, so you'll want to go to Table Set, and right here where it says Independent Auto Ask, you will want to make sure that this says Ask. That will allow you to put whatever numbers in here for x that you want. I can just keep typing numbers in there. Okay, so like I want to check -1. Does -1 work? So I'll put -1, enter. And you notice here I get 1 and -1. Are those the same? No, so it doesn't work. And I'll put 3. I get 3 and 3. So that one works because these two are the same. Okay, so when we check, you can check here on the graphing calculator by just going to the table real quick, punching that number in and seeing if it works or not. Okay. I saw this one just a second ago. Okay, we do not have our radical here alone, so we need to get it alone. So we're going to subtract 4x minus 4x. So you have -2 square root x plus 3 equals -4x minus 10 divided by -2 to everything. You know, the square root of x plus 3 equals 2x plus 5. Now this is all by itself, so we will square this side and square this side. Now be careful here. The square root and the square cancel, so you have x plus 3. But what happens over here? This is not 4x squared plus 25. This tells you to FOIL it. But we had that shortcut here that worked for us. Okay, so we will square the first one, multiply all the numbers together. 2x plus 2x times 5 is 10x, times 2 is 20x, and we will square the last. Again, you should notice we have a quadratic, so we will get everything to one side. 4x squared plus 19x plus what, 22. Quadratic formula. You might be actually I think this one does rainbow, so let's try rainbow because I think we need some refresher there. So 4 times 22 is 88. I need factors of 88 that add to 19. That's 8 and 11. So we'll break down 4. 1, 4, 2, and 2. 1, 22, 2, and 11. So we need 8 and 11. So we're gonna use 2 and 11, 1 and 4. So 0 equals 4x, 1x. So over here I took the 4 times the 2 to get my 8. So we'll take the 4 times the 2 and the 1 times the 11. They have to go in opposite parentheses. Signs are the same and they are both positive. So then we'll simply set each one of these equal to 0. So we have 4x plus 11 equals 0, x plus 2 equals 0. So x is -2, and we will subtract 11, divide by 4. So subtract 11, divide by 4. Those are your possible solutions. If we go to graph it here, clear those out. One of them is 4x minus 2 square root of x plus 3. And the next one is minus 10. If we go to the table, we get to type it in. So we can just delete these out. If you want, you don't have to. So -2, enter. We have 10, -10, -10. So -2 works. So -11 over 4. We have -12 and -10. So this one is extraneous. It does not work. We'll talk more about why they don't work. It has to do with the domain, okay, and what can and cannot be under this radical. but we'll get to that later on. Okay, with this one we have two radicals. So we're basically going to do the same thing, except we're going to do it twice. Okay? So the first thing, we need to isolate one of these. It doesn't matter which one. Okay? So we're going to say, excuse me, we're going to say that square root x plus 2 equals 6 minus square root 7x plus 2. Okay, we'll square this side and we will square this side. So you have x plus 2 equals, now over here we got to FOIL this out. Okay, but this is pretty hard to FOIL out by hand, but if we take that shortcut, we'll square the first, multiply all three of them together. So you have 2 times 6 times negative radical. Now I can't multiply the stuff underneath here, so I simply have negative 12 radical 7x plus 2. And then you square the last one. So plus 7x plus 2. Your radicals cancel out there. So now we just have this one radical here, and we need to isolate that. Okay, so we'll move everything to one side except for the radical. So I want this to be positive, so we'll move it to this side. And we'll subtract 2, that happened to cancel, minus x, minus x. So we have 12 radical 7x plus 2 equals 6x plus 36. Get our radical by itself, so divide by 12 onto everything. You have the square root of 7x plus 2. Equals 1/2 x plus 36. Okay. Now we've got two directions we can go here. I can deal with the fraction, or I cannot. And I'm going to show you both. Okay. So to get rid of the radical, we square everything. Okay. So then you have 7x plus 2 equals. Again, we're FOILing this, so square the first, 1/4 x squared, multiply them all together, so you have 2 times 1/2 x, which is x, times 36, and then square the last. So you have 36 times 36, 1296. Then you move everything to the other side. So minus 2, minus 2, minus 7x, minus 7x. So you have 1/4 x squared plus 29x plus 1294. Okay. So now we would simply just put it into the quadratic equation. And solve it. I'm thinking we made a mistake here somewhere. Let's look. I forgot to divide this by 12, right? So this is 3, which will make this 3x, which will make this a lot smaller, 9. Okay, then it'll be 1/4 minus 4x plus 7. Whew, that's a lot better. Okay, so if I don't deal with the fractions here, let's go back here and let's say I've got the square roots we get the square root of 7x plus 2 equals 1/2 x plus 3. Okay. I need to get rid of this, so I'll multiply everything by 2. So I have 2 radical 7x plus 2 equals x plus 6. So I can still square this whole side and square this whole side. So then I will have 4 times, I got to square this one, 4 times 7x plus 2 equals x squared plus 12x plus 36. Now I don't want to divide by 4 here, because if I do, I'll just get 1/4 here again. Okay, so distribute. You have 28x plus 8 equals x squared plus 12x plus 36. Move everything to one side. So you have 0 equals x squared. 12 minus 28, negative 16x, and 36 minus 8, 28. Okay, so that is the exact same thing as this, kind of. If I multiply every one of these by 4, I get that. Okay, so we can take this and solve it, or this one. It doesn't matter. Let's see, factors of 28 that add to 16. What are factors of 28 that add to 16? 14 and 2. So we'll say that 14 and 2, x signs are the same, they're both minus, 0. So x is 2 and 14. So then we check. So we have the square root of x plus 2 plus the square root of 7x plus 2 and 6. So if I go to my table, I'll put in 2, I get 6 and 6, so that's good. If I plug in 14, I get 14 and 6. So 14 does not work. X squared, or x equals 2 does. Okay, so long one there, and we got to remember these steps here. We isolate the radical. Okay, we raise to the correct power. If a radical remains, we repeat. This is a loop. You keep doing this for each radical that you have. If you got 3 radicals, you're going to do it 3 times. Solve the current equation and check solutions. This is a must. Okay, got to do this. U-substitution is a method used to rearrange a problem so that it is in a form that you know how to solve. For example, if I have x to the 4th, let's see here, x to the 4th minus 3x squared minus 4 equals 0. Okay, we know how to factor that, but let's just use U-substitution to work it out. So I'm going to let u equal x squared because I want to get rid of that. So I have negative 3u minus 4 equals 0. And this x to the 4th, that is the same as x squared squared. So we'll plug the u in, and we have u squared. Now it's very easy to see that that is a quadratic, and we can factor it. Factors of 4, that's subtract the 3. That'd be 4 and 1, u and u. Signs are different, the bigger one is negative. So then we will set each one of these equal to 0. We'll say u equals minus 1 and u equals 4. Now I don't care what u is, I care what x is. So we will make that substitution back in. X squared equals minus 1, x squared equals 4. So square root everything. X is plus minus I. X is plus minus 2. And there are your answers. How many was I looking for? Well, I had x to the 4th in the beginning, and I have 1, 2, 3, 4 answers. Now here's one. looking a little funny. It looks close to being a quadratic. So we will let u be this term right here. So u equals x to the minus 1. Okay? So this becomes x minus 1 squared minus x minus 1 to the first minus 12 equals 0. We'll just put a u in there. So u squared minus u minus 12 equals 0. And factor it. Factors of 12, let's subtract a 1. That's 4 and 3. U. We have signs are different. The bigger one is negative. So u equals 4 and u equals minus 3. We'll plug this back in down here. X minus 1 equals 4. X minus 1 equals negative 3. Now the x minus 1, that is 1 over x equals 4 over 1. 1 over x equals negative 3 over 1. That is the reciprocal. So all I got to do is flip it over. So x equals a fourth and negative 1/3. Okay. It's always a good idea to also go back in and check that. We could also graph this and look at the table. We'll look at this and then graph y equals 0, which is just the x-axis. All right. So we'll just let u be this. So u equals x to the 1/3. Okay. So this is x to the 1/3 squared. If I multiply those, I get 2/3 minus 3x to the 1/3 minus 10 equals 0. So u squared minus 3u minus 10 equals 0. So it becomes very, very easy. So factors of 10 that subtract a 3, that's 5 and 2. U, 0. Signs are different. The bigger one is negative. So I have u equals 5, u equals minus 2. Take this and plug it back in. X to the 1/3 is 5. X to the 1/3 is minus 2. How do I get rid of the 1/3? Take it to the third power. Okay, so x equals 5 to the third. So that's 5. 5 times 5 times 5, 125. And then negative 2 to the third power is negative 8. Again, we want to check those out. Okay. This one looks a little strange, but all I have to do is factor out the 1/3. So then if I factor out a 1/3, I get x to the 6/3. So I get 2. I get x to the 3/3. I get 1, and I get x to the, that doesn't matter. So minus 4 equals 0. So again, factors of 4 that subtract a 3. It's 4 and 1. X signs are different. The bigger one is negative. But I also have this. I got to keep it there. So we'll take each one of these factors equal to 0. So x equals negative 1, x equals 4, and this is the third, x equals 0. So I've got 3 different answers there. Here's just another one, factor by grouping. So we'll look at these two and look at these two. Factor out an x squared, you get x plus 2. Now I need x plus 2 in this one. So factor out a minus 1, you get x plus 2. So you have x plus 2, x squared minus 1 equals 0. Well, we needed 3 answers. Okay, here's one, but this is the difference of squares. So you have x plus 2, x plus 1, x minus 1. So that's simply x equals negative 2 plus minus 1. And there's your 3 answers. Okay. U-substitution, let me go back to one real quick, is used if I have something like this, 2 minus radical x equals 5
coding in a little bit flavor.
I can take this out and I can put a u in there. So I can say u equals radical x and say that 2 minus u equals 5. I can work all this down and then take this and plug it back into the end. And we'll do one like that later on. Okay. So here's your suggested problems. Okay. Keep an eye on them. Let me know if you got questions. This is at THS Mr. Jones signing off.